Hello, we are Images Not a Problem and welcome to Challenge 9, Visual to Natural Language Converter. So I'll give you a brief breakdown of the team. So we have the team captain, Joseph Haynes, Erblin Marku, and myself, Sheldon Atkinson. Simply put, the challenge was to create a solution which could read data contained within tables and graphs found within academic papers and reports, and then convert that data into text format so that it can be read by large machine language models. Within this presentation, we are going to run through, firstly, the problem and the associated goals, the data flow and implementation. I will give you a brief demonstration video, and then highlight some of the main benefits and then areas for further development.
So, the problem. Currently, leads are inputting phone reports found online into Chatbase, and these reports contain a number of charts which Chatbase cannot interpret or understand. This is a problem because when a user interacts with Chatbase, the user does not receive information it would expect. So, our task was to automate the conversion of all these report charts into written language for a Chatbase input. And since Chatbase understands the written language, it can then absorb the chart information if it's been converted to text. Our goals. So, the inputs we have were images and charts present on the GLEAD's website. We also had PDF reports and images. Our desired output was to automate the conversion of these reports, images and charts, and extract the raw website chart data. We then wanted to summarize the data and describe the charts in written language. Another aim was to have PDF reports to text functionality, as well as any chart image to text functionality. Data flow and implementation. So, what do? We decided basically to design a web application in which you could input the web report URL of your report. This is shown below in the bottom left-hand corner. When you click submit, we then scrape the website that you enter using Beautiful Soup and extract all the charts and chart data from that website. When we scrape through and got all the information, we then pass the information of the charts and chart data over to OpenAI and the ChatGPT API for summarization. This is then displayed using a Streamlit front end, basically a website front end, and it displays the charts that have been taken from the report URL, the raw data containing those charts, the GPT description of them, as well as a Knowledge GPT integration for PDF analysis. Now on to a little demonstration. Here you can see a report with a number of charts that one might want to analyze and take the information out of these charts automatically. To do this, we take this report URL and we drop it down here into our application. We then run the analysis. As you can see, our data scraping module picks out all the charts from that page automatically, highlights the key information from the page, and also summarizes the information using the ChatGPT tool. This is done for every single chart on the page, and it's going to speed up the integration with Chatbase in the future.
Okay, so now I'm going to highlight some of the benefits. So the main benefit is associated with reduced time and the effort to use Chatbase, and also the greater volumes of historical data which can be analyzed. So before, chart information had to be typed by hand, and this had to be done for every single chart across all reports, which was very time consuming. This was done so that Chatbase receives an input it understood. But now with the solution implemented, the translation of report charts to text has been automated for website reports, which reduces the time and effort to provide Chatbase with the text input that it requires.
As for future improvements, there are some things we could do. The first is we could do a summarization or compilation of all report data, which is scraping all the data and removing the charts and replacing them with natural language. Another thing we could do is an accurate PDF to text functionality, where you can input a PDF report and get the whole report in natural language. And lastly, we can use BART or T5 models, which are chart-to-text models, and use them to convert the charts into natural language.
Excellent. Now on to judges' questions. So the first question was, how does your solution deal with double-axis graphs and complex visualizations? So our application is currently extracting information from infogram charts present in the GLEADS Folium reports. Due to this, the data behind the chart is highly structured and can be accessed via web scraping, meaning our solution can deal with almost any variety of infogram chart, double-axis graphs, or complex visualizations.
Question 2. What features should be included in future graphs and visuals to allow them to be more easily read by your solution? Well, since our solution is the integration of web scraping and ChatGPT, all key chart data is automatically extracted with our scraping module. And due to this, we're not concerned with finding any key features, as we can bypass basically all machine learning models using this scraping method, and we can still provide a solution for 85% of GLEADS reports. In the future, we would like to include a direct image to text functionality. However, this will take greater research and a lot more time.
And question number 3, can you provide insights into the performance metrics of your solution, such as accuracy rates, processing time, or resource utilization? Since our solution does not use a machine learning model, we do not have direct method for producing accuracy metrics, as we do not train or test the model. The solution can convert up to 85% of GLEADS reporting requirements. We could provide an analytics report giving information of processing time and resource utilization if we had more time or if needed in the future.
Yeah, so I think that pretty much wraps up our presentation, and thank you very much.